In this video, we are going to talk about solving systems of equations with 2 variables and 3 variables using substitution and elimination. First things first, let's take a look at the 3 types of solutions that we can get from a system of equations. The ones that are on the screen are for 2 variables, or something that we call linear system of equations. So there are 3 types. There are no solution, 1 solution, and infinite solutions, and those are either called consistent or inconsistent and may have dependent or independent graphs or solutions. So the first one we have here is what we call inconsistent, where if I solve it down, nothing is going to solve that system for x and y or whatever your variables are. That produces no solutions because it creates 2 parallel lines. They're not going to cross each other. The other 2 are what we call consistent. So if it's independent, you're going to have 1 solution. They're only going to intersect at 1 point. You can also have a dependent consistent system where infinite solutions exist because that creates the same line. So there are 2 ways to solve these systems algebraically. The first is substitution. So we're going to do as the name says with this example is I'm going to substitute some x or y into the second equation to solve for 1 variable. Our goal is to always get it down to 1 variable if possible. So I can actually rewrite this as x equals negative 7 minus 2y. And I'm going to take this and plug it in for this x here. So when I do that, I end up with y equals negative 4. So what I'm going to do with that number is I'm going to plug that back into either one of these to get my x value. And when I do that, so I just picked the first equation. You could pick the second one if you wanted to. And I get x equals 1 and y equals negative 4, so my solution set is 1 comma negative 4. And the second way to solve a system is using elimination. So I'm going to take the same example, but what I'm going to do is I'm going to try to eliminate, using multiplication and addition, one of the variables. So I have 1x and 1x and 2y and y. So I'm going to multiply my second equation by negative 1. And that will eliminate the x's. So if I have the same signs going on, whether it's positive, positive, negative, negative, I always like to multiply by a negative, so that eliminates the step of subtracting, because that would take an extra step, and I'm all about simplifying my life. So I just want to do it 1 step. That's why I would always multiply by the opposite sign. So when I multiply by my negative, I'm going to get this, and what I'm going to do is I'm going to add this equation to that equation, so I have 1 variable left. So I just line them up over here like in a simple addition problem, and I'm going to eliminate my x's and solve out for y. So y equals negative 4, which is what I got in the last slide using substitution, so I'm on the right track. So I'm going to plug in this negative 4 into one of the equations and solve for x, and we'll see if we get 1 like we did last time. And look at that, it works out. So my solution for both substitution and elimination is 1 comma negative 4. And it should be the same because although my process is different, the 2 equations are the same. So the system, or the solution to the system, should be the same as well. So let's take a look at this example. So I have 2x plus y equals 5 and 4x plus 2y equals 8. I'm going to use elimination here to solve, and let's see what happens. I multiplied the first equation by negative 2 to make that a negative 4x here, so that these will cancel, but look here, these also cancel. So that gives me 0 equals negative 2. This is what we call inconsistent. So that means that there are no solutions. Now let's talk about the solutions to a system with 3 variables, or 3 equations. So if I was talking about linear equations, that would be 2D or 2-dimensional, so that would exist in the xy plane. What we're looking at when we have 3 variables is a 3-dimensional answer, or a solution in the 3D plane. So your x, y, and then your z. So that's what you're looking at right here, and that's why it looks a little funny, because it's not just in a 2-dimensional plane. So there are still 3 different types of solutions. We still have our consistent and our inconsistent. So starting off on the right, our inconsistent still has no solutions. It's not going to cross anywhere. You just have 3 parallel planes. So when you have consistent, if we had just one solution, these three planes are going to intersect at one point. That's going to have an x, y, z coordinate. And then you're also going to have a consistent and dependent where they will intersect on a line. And that's a little bit harder to see, but the same rules and the same kind of parameters apply in 3D as they do in 2D. So to put that into practice, let's take a look at this example. Now it's going to be a mashup between substitution and elimination. My ultimate goal here is to take one of the equations, so I'm going to take this first one, and manipulate it with this one and the third one separately. So what I mean by that is I'm going to take my first two equations and I'm going to try to eliminate one of the variables. I'm actually going to try to eliminate x just because, so that I have an equation with just y and z in it. So what I've done is I've turned this first one into something that starts with a negative 4x, so I can cancel it with this 4x here, and I get a new equation. So equation number 4, I've labeled them 1, 2, and 3. So equation number 4 is going to help us eliminate either y or z in just one step. So now I'm going to take equations 1 and 3 and do the same process so I have an equation with just y and z. So now I have a fifth equation here. So what I'm going to do with this fourth and fifth equation is I'm going to combine them and solve for y in this case. I could solve for z if I wanted to. Doesn't really matter. So after all of this work, I multiplied by 6 here to eliminate this z, and I find that y equals negative 2. So now my life is a lot easier because I'm going to take that negative 2 and plug it into either one of these equations to solve for z, and then I'm going to take y and z and plug it back into probably this equation to solve for x. So I plugged y equals negative 2 into that fourth equation that I created, and I found z to be 1. So now I'm going to take z and y and plug that back into one of the first equations that I started with. The first one seems easiest, so let's do that. So when I solve that out, I get x to be 2, so my final solution is going to be a point in 3D space, so it's going to have 3 different dimensions, is 2, comma, negative 2, comma, 1. And that's going to do it for this video. Thanks for watching.